Welcome back to the Intellectual People podcast, where we have Wayne Parham with Pi Speakers. How are you today, Wayne?
I'm doing great, Jason. Thanks. How about you?
I'm doing well. Thank you so much for asking. Well, first off the bat, Wayne, why Pi Speakers? What's the name about?
Well, it's the mathematical symbol. And the reason I chose it is that when I started doing this, there were infinity speakers, which I thought was cool. It's a mathematical symbol too, and it has, somewhat of an emotional meaning to me. I felt the same way about pi, and I was surprised that it wasn't picked up because in just about every electronics formula, especially about reactive circuits, and mechanical formulas too. The number pi figures in. So it just seemed to me a real fun name for the speaker. And then later, when it started becoming kind of commercial, I was kind of surprised that there was no registered trademark in Class 9. So I got the mark, both the word mark and the symbol mark for electronics in Class 9.
Very cool.
Yeah,
And those speakers over your shoulders must be part of your collection of Pi speakers?
they are. These are 3 pi mains, and over on the side are 3 pi subs. The fact that the subwoofer number matches the main is not significant. It's not that I have a 3 pi sub goes with a 3 pi main.
Okay.
In fact, those subs are kind of a general purpose home sub. But yeah, that's what those models are.
Fantastic. And we'll get into all your offerings a little bit later. So, Wayne, did you always want to be in the speaker industry? Did you, as a child, always look at wanting to have an audio company?
No, no, Jason, not at all. In fact, I enjoy a lot of friends in this industry, but the audio industry looks to me to be very tough to make a living at. It's also intellectually interesting, but not. I'm into computers. I'm into artificial intelligence. I do stuff that I think is a little more interesting. I got into speakers because I wanted a good pair of speakers, and I wanted the price right, and I had certain goals for them. So I got into speakers because I wanted to make these.
I see. So, what is your daily profession then?
I work for the Department of Defense, and I do software.
Software. Okay. And were you always interested in electronics and software through your teen ages?
Yes, more on the hardware side, to tell you the truth.
Okay.
Um, when I was a kid, I loved airplanes. I loved model airplanes that flew, and that then got me. And I'm talking as a little kid. I wanted radio controls, and back then it was expensive, and
Yeah.
so I started out wanting to make them, but I got sidetracked because digital circuits, and the very, very first microcomputers were on the horizon. And so that kind of derailed me. Fortunately, I started playing with the early microprocessors. And back then, if you were going to play with one, you had to make your own. It was like, they'd call them home brews. You'd have a processor chip and the gating logic, the clock. You'd build your own.
Right.
And so I got into that, and then found out I was really good at it. Won some awards in school, and then that ended up being a career. The truth is, I went into electrical engineering. My first stuff was all hardware, as I said, and but to make the things do something, you have to write a little program, and so I kind of specialized in microcontrollers. I made equipment for some of the local companies, and I'm from Tulsa, Oklahoma, that manufacturers that made stuff, and they wanted to computerize. So I could build them a computer controller, and so that was really industrial control. So the programming I did was what would be called firmware, and you'd burn a ROM, and now this thing was a device that, see, over the first maybe at about 15 years into my career, I started getting more and more stuff that was more software, and then more system software. And, I found myself in the last 20 years of my career, I've done some hardware projects, like for Walmart, the signs that tell you when you can come in and do the self-checkout. I've done hardware with firmware, but a lot of my work now is software only.
Okay. So are you in computer science, or are you an electrical engineer by education?
I'm an engineer by education. And again, that was my first effort was totally that.
Yep.
But again, doing the firmware, I often would use C.
Sure.
And so then I could, that was somewhat of an easy transition to go to systems programming using C, and then C++. And now it's more Java and Spring Boot, a lot of Python for prototyping. But yeah.
Do you enjoy the Python work?
I'll be honest. In AI, everybody uses it because there's a lot of libraries. I wrote rules engines in it a long time ago. Before this latest AI craze of the last couple of years, you couldn't get a job in AI. It's fun to read books from people like Douglas Hofstadter and Melanie Mitchell and some of the big names, Kurzweil. But, corporate America didn't want it. And even the military or DARPA only wanted it every so often. It'd come in vogue and then it'd go. And so that was not a career. But what was expert systems and rules engines. And I've written a lot of rules engines, both in Spring Boot, which is Java, and in Python. Well, but Python to me has always been more of a prototyping scripting language. And the fact, though, is that probably in the last 10 years, I think it's, Python's been around a couple of decades, but I think in the last 10 years, since there's been so many statistical and mathematical libraries that some people like to use in AI. I mean, that's, after all, what AI is statistical tokenized stuff. But they're using Python because of those libraries, I think. And I'll be real honest, I think it's ill fit. I think some of the other languages, simply because they're faster, are a better choice.
Do you think in time there's going to be an AI language?
Well, there'll be, honestly, there's a lot of different forms of AI. But the stuff that we use now is mostly genetic algorithms and neural networks. Neural networks, there's a whole hardware implementation of that. There was a guy named Frank Rosenblatt that made the first one in the 1950s. And it's basically a majority gate. At its lowest level, a digital neuron is a copy of, what we saw then in biological bodies is a biological neuron. And it has many, many inputs and one output. And it's looking for a majority of those inputs to be hot, to give a hot output. And then the way they work is a mechanism of weighting. The most important of those inputs gets more like priority. Well, today's computers are what's called a von Neumann architecture, and it's the computers that we've all known for the last 50 years, which are much more mechanical. They use Boolean logic. They use an arithmetic logic unit. They use one processor. And we simulate neurons in those. That's all the AI now simulates them. Well, those weights that I was talking about, the way to simulate that is with, you don't do it with an integer. You do it with a decimal, something with a decimal point. That's why you see GPUs all over the place, because they're a floating point, an FPU, or a GPU, a graphics processor. Both of those use floating point. They use decimals. But it's overkill. We don't need the precision, which is why, those things cook so much power. Well, sorry to diverge all the way down that rabbit.
No, it's fine.
But the bottom line is, you ask if there's going to be a language. Well, there should be a different hardware. And that's why you see these NVIDIA chips and all that. Well, the truth is those guys made graphic cards. When 20, 30 years ago, they were making VGA graphics boards for an IBM PC. They're graphics companies, and they make a graphics processor chip. The best approach, what you're seeing people making a new like AI processor would be basically a floating point unit that the precision was low. We don't need the extra precision. You're wasting cycles trying to calculate it. Then as far as a language, well, yeah, I mean, something that is better aligned with the way a neuron works would be helpful. But I'll be honest with you, I'm not so opposed to the languages that we already have to make those models as I am. I just don't think a scripting language is the most efficient way to go about it. It's not even compiled.
And that's where I was going with this. If there's a better way to do it in terms of the language.
And I think so. I think that, we'll evolve past Python. Although there are compiled forms. There's a compiler that's been written for Python. And, I suppose that could be, it could be that's the direction they go. But, Python isn't, I don't know why I'm not really against it. You can write it just like C and C++. It's similar. I don't like the little indents. I like to have the brackets in there, but.
And Python is open source, isn't it?
Well, most of the stuff these days is.
But it's true. It's free, right? Anybody can download it and use it, if I'm not mistaken.
Right? Yeah, that's true. Yeah. Right. But again, C and C++ for GNU, and, they're these days in the last 2 decades, it's become very popular to have open source everything. The irony is you heard this thing about DeepSeek and how it was open source, and that's a lie. The one thing you aren't going to have open source in is a neural network, because the source of a neural network, you can't distribute the weights. That's like the compiled binary. That's not open. If you wanted to open source a neural network, you'd open source the training data, which would be the trillions of words that went in, all the sentences, all the stuff it scraped. So that is a misconception that's been thrown out there. I'm not even sure what the goal was to say that, some kind of spin. So anyway, everything seems like has got open source except AI, which is by its very nature not open. It's it's hard to even see inside it to figure out what the heck the results of your training were.
Right.
That's one of the problems we have. Is
as somebody that works in AI, does it concern you?
No, not at all. I mean, I've loved the progress that we've made since I was a kid. Again, some of the earliest people that I looked at, Minsky from MIT and Hofstadter and Mitchell. Hofstadter wrote the book Everybody Loved Good Old Usher Bach. I remember the first thing I was impressed with was when Minsky and his team at the MIT lab, they made something and they could train it to walk, a legged robot. Sure. Yep. And I realized right then and there, that's the perfect application for AI, because think about it. A rules engine, a rules-based programming approach is something like making the recipe for a cake, specific rules that you write. And if you follow those rules, you get a cake. Okay. That's all procedural programming that we've done for 50 years, more than that. A neural network is trained. That's more like learning to ride a bike. There's some rules in there. You're training your body to make very subtle shifts to balance yourself and to pedal. You're learning motor skills, but you can't reach into your subconscious or somewhere and find out what rule set you generated to make those subtle moves. And that's the way a neural network is. That's why I'm not scared of that. It's just another mechanism, and it's really neat. And to me, it seems best served for things like motor movements and these types of things. Here's the one thing it's not good at. It's the same thing people aren't good at. If we don't know an answer, we're tempted to make up something plausible. And sometimes we're not even trying to lie to somebody or put spin in it. We actually thought we knew something and we kind of picked it up somewhere, and our facts aren't really checked, but we're sure we knew it. We make stuff up, things that seem plausible. That's exactly what the chatbots are doing. If it's just stringing together what would be the statistical next best thing to say.
Interesting.
So, as long as a person knows what they're working with, there's nothing to be scared of there, in my opinion.
And just to be clear, we're not using AI right now where you're just saying something that is computer generated, right?
How could you tell these days? That's kind of creepy sometimes. Some of the
It is.
But again, I'm not really scared of that. I mean, think about it. Even before the computers were doing that, I mean, you see people in prominent places just spinning the heck out of stuff. To me, that's always been the scariest thing.
And the models, the AI models, are obviously fed real data from people, from humans, correct?
Yes.
So the better the data going in, obviously, the better the data comes out, correct?
Well, that's right. And that's exactly what I see when I make a model or when I tune a model. If I've got real concrete data, even though I haven't trained it in a rules fashion, what I get out of it's pretty concrete. I might as well have trained it with rules. That's how it acts. If I give it a bunch of questions, a bunch of answers, I've got a bunch of stuff, and it's got the facts, it will act pretty deterministically. Where it fails is if I don't have it, and it's got to make inferences, and that's the problem. I mean, it's doing everything statistically. That's great, but we don't have a concepts vector, and that's a big deal of mine because the people I respected the most, Melody Mitchell, Douglas Hofstadter, they went back to the Dartmouth AI of the 50s where they were looking to try to make computers that could make analogies. They could understand concepts. None of our models do that. They don't come anywhere close. They simply have a statistical relationship with words or pictures or sounds. They don't know the difference between up and down, in and out. They don't understand that concept. So, in my opinion, we need to add some genetic algorithms to those neural networks that get in there and beat away randomly until they figure something out and they actually make a concept. And that'd be a whole nother vector. In addition to the word vector or the image vector, we have a concepts vector, but that's a ways off.
Well, I do have a correlation between audio and AI is that the audio system only reproduces as well as the source, right? And then your speaker.
Sure.
Right? A good analogy?
I think so. For me, this is funny. As I told you, I've been a digital guy since way back, since before there was any digital audio and way before digital video. And I can remember early experiments with digitizing, because that was one of the first things I did actually was work with, A to D converters and D to A converters and implementing them into computer systems, and using those for sensory inputs. And early digitizing of audio and putting it on a big old hard disk as big as a washing machine. That's cool. That's a lot of fun. And then, of course, we run into the early digital artifacts that you would run into, the aliasing and the kinds of problems that, nowadays we audiophiles will talk about, and as we, worry about our DACs.
Right.
And back then, everything was a successive approximation approach. We didn't have any of the 1-bit DACs like that we do now that are a kind of a different approach. But I think my point is that I realized kind of similar to how the difference between a neural network and a regular Boolean network, if you have an analog system, it's like a digital system, but its resolution is extremely high. Its sampling rate is extremely high. And, that's what you have on on vinyl and tape. That has its own set of problems, but it's an analog is simply very much like a very high resolution digital. But the same could be said about film. We all love our digital cameras now, but film resolution is higher, and the reason is because the actual grains of the film are small. So yeah, that's adjacent to AI. It's digital technology versus analog. And
Right.
in my systems, my speakers, it's also I could use digital filters. Everybody is these days, and that is my world. And it makes things a lot easier. But I also come from a time when everything was analog and digital was still a bit of a dream. And so I'll always make an analog crossover. And
Really?
even when I'm testing, even when I'm testing and I'm using digital filters to test with, because it's easier to manipulate. But my goal is always to make a filter that does exactly what I want it to do. The crossover between that tweeter and that woofer. Yep. I want to be able to build that with real parts that I can buy from Parts Express.
Why?
So I'm limiting myself to filters that can be built with analog components and analog components that are like a 6.8 microfarad capacitor or a 4.7. I don't want a 4.327. I want physical components that I can buy. And, I can do that, because if you you could shift parts around in the design process and get the exact phase relationship you need. It's just, that's a goal of mine, is to always make sure that the analog, that I can do with analog parts.
Do you think that analog parts has a different sound than doing it in the digital domain?
Yes. But I think the reason is I'm kind of a measurements guy.
Sure.
I do appreciate, let's sit down and listen and have a subjective feel.
Okay.
But way back, even before I could afford measurement gear, I was real particular about my mathematical models and, getting it right kind of intellectually, So I really lean heavily on my measurements. I want to understand what measurements are important, of course.
Of course.
But I say that because, if a guy made a digital filter and he did all digital stuff and he did it with a high enough sampling rate and high enough resolutions, then, any anomalies you have are way outside the bandwidth that our ears could hear.
Right.
You do that, the digital stuff is going to be every bit as good as the analog. The problem is that sometimes we don't. So I think that's really the answer for me is, what are your limits? What are you working with? And make sure that those limits aren't impeding in on the things that you can perceive.
And the other half of this with doing it in the digital domain is that you're able to take in the room effect as well, right? Which is a huge advantage.
Yes, I think that the thing that I find most useful about digital is it is so highly variable. You can do so much with it with typing. You're not having to physically remove a part. But I will tell you this, that's a big deal of mine, is room effects. That's why I like horns. And I don't like just horns. I like waveguides, which are designed with directivity in mind. And that is because you want the sound where you want it, which is essentially saying that you're trying to work around problems caused by room acoustics. I'm also a big advocate of multisubs. Same deal. That's a room acoustics thing. But what I find very important there is room acoustics are 3D. That's huge. That is a huge concept to always bear in mind. The problems that you run into are three-dimensional problems. There is no electronic circuit that solves that. You could solve it at one place, and you could probably solve it in one plane, but you can't solve it 3D. You just don't have the ability to get that extra dimension. So it doesn't matter digitally or analog in some respects.
Okay.
An example again would be the room modes, the multi-sub.
Sure. And we're going to definitely get into that.
Oh, okay. Yeah.
So when did you build your first speaker?
Well, that's way back when I was a kid.
Okay.
And my whole goal then, I frankly, my whole goal then was to get something in a budget that sounded like I had a bigger budget. My money was small and my desires were big.
Yep.
And back then it was a lot like what I now offer as a 1-pi or a 2-pi loudspeaker. It's just a cone, woofer, and a little bitty horn tweeter. And the things that influenced me back then were I grew up in Tulsa, Oklahoma, so I was pretty near to Hope, Arkansas, which is where Klipsch was. We had some Klipsch dealers. That was one influence of mine. Another one was Infinity, whole different ball game. They had those Emmett tweeters and the EMEM mid ranges.
Yeah,
I liked the crispness of the high end. I didn't like the fact that they were easy to blow. They were just so fragile, really. So your dynamic range was limited, even with the big, huge Infinity arrays. And then I liked the Altec and JBL. They were just powerful speakers. Sure. But some of the products made by those companies, and by this time Altec was, by the time I was a kid, Altec was defunct. But JBL wasn't. The problem for me was some JBLs were awesome and some were terrible. And I later learned that's because they were designed by completely different divisions. There were a lot of divisions in the company. Okay. But I learned this a little after, when I was working and into my career and had some disposable income. I learned that the professional series JBL parts, the stuff they'd use in concerts, were what I liked. The larger studio monitors that they made, and then the stuff they were using in Pro Sound.
Yep.
So that transitions me from the earliest ones, which were really mostly budget and didn't control directivity. When I moved into the higher end stuff, I had a little budget. I was first attracted to control directivity because that was a big deal then.
When was that?
JBL was. That's late 70s, early 80s.
Okay.
JBL, for example, they made the 4430 and the 4435, which had the butt cheeks tweeter. That's what everybody calls it. You remember it's
yep.
And they also back then made the 7430 horn, which was a controlled, or it was a constant directivity horn. But the thing that I liked the most, they had the 2205 woofer, super powerful. I still use that as, or that family of speakers. They had like the 2115s, the 2105 mids. They had that 2405 bullet tweeter. So those were influences on me. Where it all congealed was, the Klipsch horn, super, loved it, loved the idea, but they were a little shrill. I think they still are. They do some things very well, but the vocals are a little gravelly. Well, that's because the bass horns run to 400 hertz. You're getting vocals through the bass horn. Now, I don't know, there's no way I'm going to diss that company or that man. I mean, that's 1940s technology. It's incredible. Yes. For the era that it was built in. It's still pretty great stuff now, but
for sure.
But I knew that it could be given some finesse, and what I kind of tried to do was take those really good JBL parts and put them in a Klipsch horn configuration, and some magic happened because just by luck I was using CD horns. And you take a corner horn and you put CD with it, and what happens is it makes the whole room. There's not a seat in the room that's bad, right? Because they're sitting in the corners and they radiate a 98-degree uniform pattern. it's magic.
Yes.
But I didn't really know what I was experiencing early on. I just knew it was great,
And how old were you at that point?
This by the time now we're getting into my 20s,
20s.
you know,
Okay.
yeah, early to mid 20s.
Okay. So you've got some education at this point, right?
Yes, right. And by that time, again, I realized that that there was a trick in having constant directivity there. But honestly, I think in the beginning, I largely thought why these things were better was just the quality of the drivers.
Hmm.
Though, as I kind of went on and read more, I believe it was the JBL. I think one of the guys that wrote, one of the main designers of the 4430, I believe, wrote a white paper on it. They were crossing their speakers like these are, where the axes cross in front of the listeners. That's the same thing corner horns do, and they do it naturally. So I began to realize, that the trick was, if a person is sitting anywhere between these two speakers, if you sit closer to this speaker, then you're off axis from it because he's pointing in, but you're on axis with this one. You're further from him, but you're on axis. Well, that trades, the difference in SBL of being closer to the speaker counteracts the difference in SBL of being off axis. So they're not an exact trade, but they're close. And so I found, to me, that was the magic. Now, I've been in rooms that didn't work, but it's huge rooms. It seems to me there's somewhere between about a 20 to maybe 50 foot, a 20 or 30 foot room is pretty big for a home room. And if you're in a room that size or smaller, you could be corner horns. You can be, if you don't have good corners, you could be a speaker like this where they're, made to sit, not in corners. But in a room that size, you can do that axis crossing thing and get the magic of anywhere in between those speakers. You've got a sweet spot. But again, that does require constant directivity.
Sure does.
And now we'll move forward to more like the 2000s. Now we're coming forward a long way. And, that's about the time I remember PV, Charlie Hughes. And I liked PV horns and didn't know why. And I think I liked them, though, back when they were still making radials. But Charlie Hughes wrote a paper on a horn that instead of using diffraction slots, most city horns have a diffraction slot in the throat and sometimes another edge to combat waistbanding. And so these things got pretty hard diffraction slots in there, and they sound harsh. They sound spitty, which is why for a long time I stopped using those and went back to radial horns because they at least have uniform directivity in the horizontal and nothing harsh. They sound smoother because they're, no edges. But Charlie Hughes wrote this paper, and basically he stopped putting those hard edges in his constant directivity horns. And he called it a quadratic throat waveguide. Or he may have called it a quadratic horn. But the point is, instead of having a diffraction slot with an edge that fractured it, the plane wave front that coming from the compression driver, which is basically a straight line, and it fractured it into a spherical radiation pattern, and then the walls confined it. Instead of fracturing it, he has a nudge. It's a radiused horn. Quadratic basically just meant radiused. And they really were smoother. And then Earl Geddes also pioneered what he called oblate spheroidal horns. The expansion then is based on the geometry of an oblate spheroid. If you intersect its, tangent to it, it's oblate spheroid is the shape of like an oval. And then he also describes a prolate spheroidal, which is more like a kind of a football shape, or an elliptic cylinder, which is a cylinder but squashed.
Yep.
And any of those, if you base your flare profile on that geometry, you get something similar to PVs, to Charlie Hughes's. Basically, all of these devices is at the edge, it's almost conical, but at the throat, it's gently curving to match the exit angle of the compression driver. So that kind of completed the magic. That brings me to kind of where I am today. It's a constant they're all constant directivity, but they use a waveguide that's really, really smooth.
Whose waveguide do you use?
Well, that's
Is it
mine.
yours? That is yours.
Yeah. I as I began to shift to the to the ideas that I'd learned from Charlie Hughes and Dr. Geddes, I was making wood horns for a while that had that kind of throat and that kind of flare.
Okay.
I think technically Geddes would say I was using an oblate spheroidal throat and I was transitioning to an elliptic cylindrical flare. Others, if it's an oval mouth, that would be an oblate spheroidal throat transitioning to a prolate spheroidal mouth. Either of those would have been fine for me. But so I was making wood horns for a while. They're beautiful, look great on top of my corner horns.
Sure.
Man, they were expensive. Even with CNC machining, and I got to pay somebody to do that. But then, if you're going to go to that trouble, you're going to use something like bird's eye maple. So you're taking a block of wood, and by the time you're done, you got the price of a car. These are thousands of dollars, and I'm like, man, I can't do this. So my entry level stuff and most of my kits would be, I'd use a radial horn because again, it's pretty close. The place it doesn't give you constant activities in the verticals, and those are kind of squirrely anyway on no matter what you got because of the knolls that are out there. But long story short, I considered to get a better price than those wood horns. I considered, using 3D printing, and this is like the late aughts, around 2010.
Sure.
So 3D printing was still kind of in its infancy.
Sure.
And, I didn't really like the quality. I certainly didn't feel I could support a compression horn on the back of this.
Understood.
Well,
and it was also very expensive at that point. It was also very expensive in the.
Well, it was. You could get the little maker bots or those.
Yeah. Sure.
Yeah, but
even large scale printing was very expensive at that point.
It was, yeah. And so I considered, and ultimately did get an injection mold made. There were some other, options. There was this guy named Evan Flavel. People called him Zilch on DIY Audio. And he was using a JBL waveguide that was pretty good. I could have seen me go in that direction. There was a group of hobbyists. Oh, and they call themselves Econowave. And they were kind of kindred spirits, a lot of commingling between my Pi speakers, hobbyists, and my forum and the Econowave forum. There was a lot of we were kindred spirits. And there was another group too that had they were sprung off, and they were a lot of Pi guys too, or similar folks. And they ultimately had a waveguide made that's more what I would say oblate spheroidal throat and prolate spheroidal mouth. And I considered that, but that one, there was always something it wasn't quite the way I'd have done it. They were all good, but in particular, a lot of them were a little short for my taste.
Understood.
And a horn like this, a waveguide like this, the thing that, you really only have its angle to set. That sets everything else, because that's just the way oblate spheroidal, prolate spheroidal, or elliptic cylindrical, the geometry, there's only one parameter. And what I found is that somewhere between 80 and 90 is perfect because I still get that, the angle that works really well in a house the toe in and all that stuff, or a corner horn. You're still within the wall angle of the corners, going from the apex of your room. So I don't want to have something really narrow like a 60-degree horn. That doesn't fit. But I also don't want wider than 90. But 80 and 90 is real sweet, because when you do that, you still have a horn that's long enough to provide acoustic loading. And that's one place I differ a little bit with some of the other waveguide people. Okay. I like to have my waveguide still provide acoustic loading like the horns of days gone by, the exponential horns and the hyperbolic horns, that their main goal was efficiency. They were being an acoustic transformer. They were making the thing loud. But there's other benefits to that. They are also reducing distortion, and they're making the response smooth. It's just that kind of horn is only good on axis. Off axis, it has collapsing directivity. It's not constant. It's not a constant. So all that to say, I chose to have my own flare. It matched what I did in the wood horns. It's a little longer. I trade off on this one because I wanted it to fit in some existing designs I had. I wanted to make it a drop-in replacement, so it doesn't have a lot of round over in the mouth area.
Okay.
But that also means what you get when you round it over at the mouth is you reduce this property called waistbanding, which is the tendency at the very bottom end of its response curve for its radiation pattern to kind of narrow in and then expand out to omni. It's this weird property. The round over at the mouth helps reduce that. But again, it does what I'm talking about. You do that, and now you got a much larger mouth. So your distance between centers is larger. So your nulls are closer together. Didn't like that. There were a lot of competing priorities that I tried to address to come up with that. So that's my that's called an HC or an H290C waveguide.
What does the H290C mean?
Well, there was the radial horn I used in a lot of the speakers before making this waveguide was an eminence horn. It was a radial horn, and it was called an H290. And they also had a B, and so mine was the C. It's the same. It's a drop-in replacement for that horn, but it's not a radial horn. It's a waveguide.
And do you sell your waveguide? Can someone just buy your waveguide, or do they have to? They can.
Yes. Yeah. In fact, probably the most popular way I sell products is I'll sell like the crossover and the waveguides, and that's it. Sometimes just the waveguides, and then people will go and source their own parts. Now, I sell whole kits also, and that's also pretty popular. But especially overseas customers, the only thing they can't get anywhere else is the waveguide. So they'll buy the waveguides. They'll use freight forwarding to keep the price for the freight cheap, and they'll source all the rest of their components themselves.
Can waveguides be scaled down and you still get the same effect as long as the compression driver will fit the throat?
Well, yes and no. I mean, when you get smaller, you lose pattern control, and you also lose acoustic loading. And typically the frequency, the bottom end of the curve shifts up. So, the larger the horn or the larger the waveguide, typically the lower its bandwidth is.
So with companies that have what they call a waveguide built into the front baffle on call it a studio monitor, right? A small 13-inch, 14-inch tall monitor. What is really happening there? What are they really getting?
Most of those, when I've seen a curved baffle, I mean, you're not going to get any pattern control out of that. It's just a curved baffle. And, even when, like I said, when I've seen waveguides that were, a couple of inches deep, maybe 3. So that's more than you're going to get out of a baffle. But even that, Um, I've seen those where it's providing no loading at all. It is providing some directional control by that size, but there's no acoustic loading, and they get quarter wave modes. You'll see those in the crossover. You'll see several tank circuits in it, several notch filters, because its response curve has got it's got a lot of ripple. And I'll be honest with you, before working with waveguides, when it was still back to the radial horns, if someone would have told me that I had essentially a conical horn, because that's what they act like, and I made it too short, I would have thought it would have done nothing. And I would have expected, if it was too long, to get quarter wave modes, like a transmission line.
Sure.
Well, so I was really surprised that I have seen a bunch of waveguides that they're too short and they get that quarter wave mode. It's not from being too long, it's from being too short. And I attribute that to their acoustic loading. They're just not getting the loading.
Has anybody put an actual spec of the minimum sizes or dimensions of each dimension that really makes it now a waveguide, rather than anybody saying, I have a waveguide? Meanwhile, it's not really a waveguide.
No, I've never seen that. And I suspect that wouldn't happen because, people be kind of sort of maybe telling on themselves. And that's maybe not fair. I mean, everybody's got their pet project that they love. But even the term waveguide to me is weird. If you think about it, not so long ago, a waveguide was, a duct for microwave.
Right.
And at the end of that duct, if you were going to transmit it, would be a flare, and they called it a horn. The fact that we call these acoustic devices waveguides when they're really a horn flare, that is weird to me. But I understand it. Their main focus, their main goal is pattern control. It's not acoustic loading. But see, so there I think is the rub. There is a spectrum of what you can expect to get out of it. When you change certain parameters, you'll begin to get more and more acoustic loading. When you change other parameters, you'll begin to get more uniform directivity, but maybe lose some acoustic loading. Certain parameters can help with the waistband. That would be the roundover, the edge section. But then they too then decrease acoustic loading, and there's a spectrum of things so you're optimizing those parameters, and you really couldn't say, oh, well, there's just, this is your minimum length, because the real way to say that is it's the minimum length for what,
What driver goes to your waveguide?
The entry level is an Eminence PSD 2002. The upgraded one that I offer is a BNC DE 250. There are the truth is the compression drivers. Most of the time, I'm leery of swapping parts without doing a lot of measurement and testing, because you usually can't get away with that. But I will say that compression drivers tend to be pretty interchangeable these days, as long as you take into account the voltage sensitivity.
Is there
anyway? That's the two I use: is the 2002 and the DE 250.
Is there a drastic difference objectively?
There is a difference objectively. There's measurable. They've got their peaks and dips in a little bit different spots. The DE 250 to me sounds a little smoother. Okay. And it shows in the response curve. The real, if they're a really good product is, TAD makes some high end drivers that are, they have beryllium diaphragms, and they're even better, but they're very expensive. They're like $2,000, and you really only gain like 2,000 or 3,000 hertz at the very top end. Gotcha. Still, if the guy's got to have if he's got to have that's available too.
And that will mount to your waveguide?
Yes.
Okay. Now, have you ever tried the Getty's foam plug in your waveguide?
Yes, when he was, when he brought out his, I stuck it in there. To be honest with you, no disrespect, the guy's the superstar.
Sure.
But I found that it simply reduced the amplitude just a smidge, just like you would expect. I'll be honest with you, I don't, measuring and finding high order modes is difficult to do. They are fairly low amplitude. Um, you can measure ripples in response in, say, a horn with a diffraction slot. You will see that ripple. Geddes would explain that the reason that it's harsh is high order modes, and I don't doubt that. But to find those modes at the angles that they are is more difficult than just seeing that ripple. So I think what I'm trying to say is it's hard to objectively measure what you're doing when you put in that foam, other than that the amplitude goes down.
Where are you planning to go with your waveguide or your speaker offerings? Because are you content with what you have and that's it, you're done? Or are you always thinking about that next step?
No, to tell you the truth, do you remember where I started? And it's where I still am. I wanted to build speakers that I liked at the right price point. I'll be honest with you, I'm kind of a perfectionist. I am in all my hobbies. And I super focus on something and make it as good as I can make it. I mean, when I'm done, I think it's perfect. It's as good as the part you could buy. It's good. And I'm done. So when I enter a project, I intend to do it to completion, and then I live with it. And I don't change it until and unless there's something significant I can see a reason for. So the my speakers evolved in like the 80s to a point where I was done by 1990. I had a line of different stuff that I liked. The internet comes out. I put those things online just for fun if you want to build them too. The forums kicks in. It starts getting popular. I start making kits, because I could buy. So many people were buying them. I realized I could get discounts from Eminence and Parts Express, and I could sell these kits cheaper than a person could buy them by economy of scale.
Sure.
But I was done. Then in the 2000s, when I started learning about Charlie Hughes and Geddes, and I remembered, oh yeah, the reason I got away from constant directivity horns, they sounded spitty, and I went to radials. So see, there was something that I really wanted to engage in. And that's when I brought out these horns and the wood horns that preceded them. Honestly, I put a lot of effort in those, and I'm done with them. If there was a reason for me to change, okay, I would. But no, the reason I changed to those waveguides is the fact that we were now making a constant directivity horn that wasn't spitty, and I've got one. Another thing that happened was the multisubs. That was Todd Welty of Harmon. That was his baby. And then again, Geddes too. But I wasn't even a subwoofer guy prior, in the 90s and before. I didn't like them. Right. And I think I didn't like them because most people, if they had a sub, it was one, which is a worst case scenario.
That's right.
But when I read Welty's work, I knew he was right intuitively. And I began to implement that. And then in talking with Geddes, and Welty liked either four corners, which worked great with my corner horns, four corners, four wall midpoints, or two wall midpoints. That was Welty's thing. Geddes said, that's cool, but I'd rather have a little bit of randomization in the room. He says, I want one corner, one wall midpoint, and then a third at a random place that's not in either of those two. Okay. Both of them would agree that once you get to four subs, they kind of found this out empirically. Welty had modeled with like 5,000 subs, which is way overkill. It's perfectly flat line when you do that. But both of them would agree that if you got to 4 subs, once you got there, it almost didn't matter where you put them. And then they both also started to do little tiny subtle nth degree things by adding some digital filtering. But really, once you get to 4 subs, it doesn't matter what else you do. It's really smooth, your room modes. But my point is, those two things changed. They influenced me, and I implemented them. But right now, today, and since then, which has now been a little over a decade, I'm done. My systems are as good as could, in my opinion, as good as can be made with today's technology. And the only time I change one is if I have a driver go out of, it's become not available anymore, and then I have to redesign to replace that driver.
Okay. So there hasn't been enough gains in driver technology that you can improve your overall design?
Well, in my opinion, for example, my one of my favorites is the JBL 2226.
Yep.
And before it was the 25, and before that was the 05. They had invented that technology because Alnico got expensive for them, and they wanted to improve a ferrite motor to be as good as Alnico, and they made one that was better than Alnico, mostly because the flux modulation, the natural flux modulation that was mitigated by the electrical conductivity of the Alnico, they were able to get that by putting a purpose-placed shorting ring in the motor. And then since they're doing that, they could place it where it was the most advantageous. So now it's not just a happy accident. They're putting it where they want it. So after they went from the 2205A to the 2205H, A was Alnico, H had a shorting ring. I mean, they then made as good as it gets, in my opinion. They have the differential drive stuff that they've begun to make. I've tried it. I like it. But I'll be honest with you, I like their shorting ring approach better. So no, I didn't shift there. Other technologies, I have found other manufacturers, some that make really good products with shorting rings. But that's been my focus. The driver, my best drivers, especially in the mid bass through the mid range. I don't really care about it in the sub range, and I don't care about it in the tweeter range, but mid bass up through upper mid range, I gotta have a shorting ring for the best performance, and you can measure why that is. And the other one is, since I'm using this isn't so much the case in the corner horns, but it's definitely the case in my two ways. I gotta have a driver cone that has a well damped. It's well damped. The cone has to be damped because I'm using it high enough that it's past the place where the cone's gonna flex. That's a break-it mode. It's got to be damped. If it's well damped, it's not a problem. If it's not, it's a huge problem. So, yeah, there's been driver technologies that I've had to wanted to embrace over the years. But, another way of saying it's just, I'm buying good parts. It's important the parts that I use are, good.
Do you find that there's much difference in quality of your crossover parts?
Sometimes. For example, it wasn't so long ago that if you needed a big capacitor, it was electrolytic, and those are horrible. I mean, you could definitely hear the difference between a 20 microfarad non-polarized electrolytic, even with a bypass capacitor. You can hear the difference in an electrolytic capacitor and a polypropylene.
Why?
The linearity. I mean, you could even see that. You can put it on an oscilloscope and see it looks like a load line of a tube or a transistor. you'll see the electrolytic. It's not linear.
Interesting. Okay.
Yeah. So you can find it in capacitors. I'll be real honest with you. It appears to be more of a technology thing than a brand. There's many fine brands of capacitor. Um, you know, so I'm not so much brand sensitive as I am technology sensitive. Similarly, the resistors. I mean, everybody likes mills. I do too, and mills aren't so expensive that I would hesitate to put them in. I love them. That's what I always tend to use.
Okay.
But you'll find an awful lot of like, Vichy or even generics that the resistor. I mean, we're not working at UHF frequencies, so the internal inductance isn't a huge problem. And they wind, it's a wire around resistor. They'll call them non-inductive, but they do that by winding them differentially. One winding's one way and the other winding's the other, and it does tend to counteract. And at audio frequencies, that appears to work very well. So again, I'm not terribly brand sensitive there. The coils, I really like to stick with air core coils. That's my sticking point. If I've got to use I won't use a laminated coil unless this thing's got to be used at 100 hertz or something. Then you'd be better with a digital filter. There are some exceptions, but generally air core is a sticking point for me.
Can you explain to the listeners what an air core coil is?
Yeah, it's just it's a coil of wire that has no metal in it, other than the coil itself, the copper winding. The inductance, the property of that coil, then is derived solely by the winding itself. There's nothing else in there. But those are limited in the amount of inductance that you can make. And so long time ago, 100 years ago or more, manufacturers would make coils and they'd put metal in there, iron, some ferrite metal, which would then raise inductance greatly. So you don't need as many coils. You can make it cheaper and it can be physically smaller. But the problem is that the core, the metal that's in there, you're literally magnetizing and demagnetizing, and it has a property called hysteresis as a result, which is a time delay. It's a slight time delay. You don't get that with an air core. They make them laminated to try to improve those properties, but that basically just means very thin sheets of iron with, like a glue. They're gluing them together. You'll find that in transformers, like in a tube amplifier. They have to have metal laminations in there. They just have to get the inductance right. And those guys, they have to do a lot of tricky work to balance all the variables so that their hysteresis isn't too bad, but they've got the proper amount of inductance and coupling between the windings. That one's tricky. But yeah, for us loudspeaker guys, just use air cores. You're good.
Got it. Are you sensitive to wires and connectors and all of that other stuff?
No, I'm not. And, I try to not step on any toes because some people, that's a certain breed of person that, they're, to me, it looks like they're talking about the number of angels that dance on the head of a pin. They're really sensitive to connectors and cables and some stuff that to me is not my focus. Sure. For me, I want, the same thing that engineering school taught you. You want a conductor that can handle the current, not a lot of internal resistance. And having multiple strands helps with the skin effect. So the frequency that could pass through it's higher. But even that in audio frequencies pretty low. You're not running into those problems. But I like a pure copper, and I like it big enough to do the job and then some. So a 14 gauge stranded, lots of strands, pure copper, I'm good.
You're good. And your capacitor plus or minus 5%, 10%, what do you prefer there for a
To the
polycat?
truth, tell the truth, it depends on the crossover. And I'm always able to get a 10% capacitor. That works fine. But I will tell you what's fun. There is on the Pi Speakers forum, go to pispeakers.com, go to the forum, go to the FAQ. In the FAQ, there is a post, and I believe it's in the measurements section. There's lots of little sections. This one I think is in measurements, and it may be in crossovers. I don't know. But the post is called, I think it's optimization for a die match two-way loudspeaker. And what that has is it shows the SPICE model, which is text, of my crossover. And see, I use that SPICE model to build a digital filter, a digital crossover. That's how I design. And it describes my process. And then there's a video linked in that thread to where you can see me measure one, and you can see me move the microphone around to find the vertical nulls. Now, where I'm going with all that is this. The capacitors that I choose and the values that I choose, as I told you in the beginning, I need to make it where it'll work with a value that I can buy, a 6.8 or a 4.7.
Right.
That means there's a window there that matters to me. And so some of those windows are going to be narrower than others. But, when you change that, if you change that by 10%, you go from a 4.7 to, say, a 4.2.
Right.
The biggest thing that's happening really isn't the on-axis frequency response. That's barely perceptible. But you are shifting the positions of the forward lobe is shifting up or down a little bit, just a little bit. And I'm using my hands to demonstrate that, because where my fingers are things called vertical nulls. And what those are is places in 3D space where the interaction between the sound coming from both of these drivers, the tweeter and the woofer, in the crossover overlap region, they're both making sound. When I get up above it, I'm closer to the tweeter than the woofer. And there's a place where that difference in the time delay from that distance, the difference in the distance makes a little different delay between the two. There comes to be a frequency where they're 180 apart, so they make a null. The one above it and the one below it, that's an upper vertical null and a lower vertical null. And when I choose those capacitors, I'm setting that. And all of my designs, I'm setting it for above and below 20 degrees. That's a big goal. Well, that means my window is pretty wide. If I shift that thing 2 degrees up or down, I'm still, 18 to 22 instead of 20 to 20. I can put these speakers on a stand and move them a little like this, or I can move those capacitors, 10% or 5%, and that's all I've done. Sure. And that's my goal in a lot of my designs, actually, is make it where the wiggle room doesn't hurt you. Make an overdamped design so that any electrical shifts don't shift it even anywhere close to underdamped. Underdamped means peaky, big old tubby sounding. I don't even want to get to critically damped. I want to be a slightly overdamped. So I do that with my designs. And I also want those nulls. I've seen speakers made by people that I trust. They're great. They're people that we all, not going to mention a name, but
sure.
I've seen it where they'll put that vertical nulls where one was 7 degrees below forward. 7 degrees. Man, that's too close for comfort for me. That's straight in your face.
You mentioned earlier about how audio is a 3D space, right? Can you explain exactly what you meant by that?
Yeah, that was a great segue, Jason. The thing I was talking about with the nulls, that's a 3D thing. We can't equalize that with a graphic equalizer. I could throw as much power as I could put 1,000 watts into that speaker, and all it'd do would be the null would stay the same. It'd still be the same suck out. There was no way to do that because it's an interaction between things, sound sources in 3D space. Well, similarly, the reflections off the walls are that way, and the cavity resonance that occurs, the room modes, those are all in 3D space. If you were to take 100 microphones and place them all through your room in a big array, you'd see, and particularly below about 200 hertz, you'd see that for every frequency, say 50 hertz, 60, 70, 80, you'd find that some places that sound was really loud, and some places just a couple of feet away, that sound was really low. It's like a checkerboard in your room. And the checkerboards, the size of the black and red squares, the size of those changes with frequency, and the positions change with frequency. It's kind of like if you look in a boiling, or you look in a pot of water or something, and you thump it to where you can see the standing waves inside of it. Put two of them, drop two things in there and watch the interactions. That's what's going on in your room. And that's a 3D thing. So that's why, you can't do anything in one place to affect a problem that you have. There are some places that you just can't affect without physically moving something, because it is a 3D problem. And then that brings me to the room modes thing. I mentioned 200 hertz. That's, some people would call that, that is called the Schroeder frequency. And what that really means is, above that, your room is acting, there's enough interference from interactions off the reflections and the cats and the dogs and the furniture that the sound field becomes a mix. It's dense interference. It's kind of like looking at water on your swimming pool or in a pond and seeing rain fall upon it. You don't see discrete waves. You just see all of this stuff, and it kind of continue. It makes the surface of that pond or that pool is pretty flat. It's got static on it. That is then what's happening in the room above 200 hertz, and that's called the reverberant field. And so it's pretty uniform. You still sometimes need room treatments from reflections. There's a lot of stuff happening, but in general, that's what you're working with above 200 hertz. Below around 200, and that depends on the room size actually, but by room size, that frequency, whatever it is, it's called the Schroeder frequency. And below that, instead of having those raindrop ripples, it's more like you threw two rocks in the pool. And you can see the waves coming from that one rock. They're spreading out, and they're very well-defined ripples. And then if you put two instead of one, then you see them interact together, but it's still very well-defined. And what you see is what I described and likened it to a chessboard or a checkerboard, where there's, hot spots and dead spots. Well, that's where Welty and Geddes came along around Y2K and said, well, let's try to make dense interference at the bottom end like we have it in the top end. Let's make a reverberant field down low below the Schroeder frequency. And the way they suggested to do that is to put a whole bunch of sound sources in the room so that you're not having just one. And then the reflections from the walls, which are a small number of reflected sources, one main source, and all six walls is that's still very few sources, sure, or reflected sources. When I put a whole bunch of woofers in the room, well, I've created more like a reverberant field, and that's where the multisub thing comes from. I added to that on my own. Another concept, that's what these are. I call them flanking subs. Then you got other subs further out that are multi-subs. But flanking subs are a bit of a hybrid approach. And I only need them with this kind of speaker. I don't need them with corner horn. And this is what they do. They're a part of the multi-sub. Corner horns, the drivers are tucked right back in to the apex of the room. And so the side walls are a launch point. They're not really a reflector. They're a ground plane. They're a launch point. You don't have a problem there. But, not everybody has good corners, that would work. So you get a speaker like this and you can solve a lot of the problems that you get a lot of the benefits of a corner horn. You get the tone and everything, but you got one big problem. Your launch point is at the apex of the corner. And so I get a reflection off the wall behind me. Now, that's called boundary interference. It's very similar to a room mode, but a room mode's more of a cavity standing wave thing that sets up self-interference off of a single boundary. It's sometimes called SBIR. That's a lot like the vertical nulls I had. It's interactions between a small number of sources, 2 in this case. That woofer is coming straight at the listener, and say the listener is 10 feet away. So there's a set delay that we could calculate. Then, since at low frequencies the sound's radiating omnidirectionally, well, then it's hitting the wall behind it and then going to the listener. And that wall behind is not so far that the amplitude is reduced from distance very much. So that sound reflected off that wall is almost as loud as the direct sound. And that wall is like 3 feet away. So 3 feet there, 3 feet back. Now I got a 6 feet difference. 10 feet direct, 16 feet reflected. And they're both almost the same volume. There's a frequency where those two are out of phase too. And what I find is that that's at around between like 90 and 120 hertz. It depends on how far you are from the walls. But, here's the tricky thing. You look around the internet at people's measurements in room, and you find a ton. Everybody's got a big old hole between 90 and 120 hertz. And that's because out of convenience, we got to live in our rooms. Sure. If we're not bajillionaires, we're living in a room that's not as big as a football field. So we can't pull the speakers out in the middle of the room, and they're a few feet from the back wall. So this is a very, very common problem. And so I had in my head a few things. Welty and Getty's multisub. That's in my head. But they can't cross over that sub that's clear across the room above 80 hertz or so, because you'd hear voice coming from it. So it can't help the room modes above about 80 hertz. So you've got half of the frequency up to the Schroeder frequency we can't cover. 80 to 200, we can't solve those. Now, in fairness, they become less and less a problem above about 100 hertz. So a lot of the multisub guys would disregard that, but it still exists. But then we got the other problem I just mentioned, the bounce off the wall. I remembered JBL made the 4430 with the butt cheeks and the 2205. They also made a 4435, which was butt cheeks, 2205, and another 2205 right beside it. And they ran that second 2205 to improve the performance below 300 hertz. It was specifically because of the baffle step. One woofer starts being omnidirectional, and so it appears that the on-axis energy is 3 decibels lower. It doesn't appear it is that much lower on axis, but that's because the energy is going elsewhere. And the truth is the energy is still in the room. It's just not on axis. They put that second woofer in there, that helper woofer, because that lifts the on axis response. Well, you see a lot of mini monitors, they do that with a baffle step correction circuit. And basically they turn the whole response all the way down to maybe a couple hundred hertz, wherever their baffle is large enough to set the directivity forward. Well, that's throwing a lot of power away. So I liked JBL's approach with that second woofer. So I threw all this together in my brain around Y2K, the multi-subs, and a friend of mine had me measuring a line array and giving him the responses just for publishing or whatever. I did that and I realized, oh, wow, there is no such thing as floor bounce from a line array. And the reason, it was a light bulb moment. It's something that I would have known, but not considered. Any of these like 8 drivers, bouncing off the floor, where one has a notch, the other 7 don't, because they're in a different position. So none of them, there's no place where they're all having a notch, so you do not see a notch. And I thought, well, duh, why not do that with that notch from the back? All I got to do is take the 4435's helper woofer and put it in its own box and make it in a different position in 3D space. So that's when I started my little mantra of, get your other woofer and put it a couple of feet beside, below, and behind the main. And the first ones I did have the exact same woofer. And then you can cross it with just one coil. And it's basically just like the 4435. Later, I thought, well, let's even go a little further and let's put a real sub there, because it's not hard to find a direct radiating sub that'll go up to 200 hertz. That's not asking much. And so that's what I do. I run them up a little high. They then, overlap together where that notch would be. So where one's notched out, the other one isn't, and vice versa. And it really does. It reduces that notch from about 20 decibels, 15 or 20 decibels down is what you'll see them. But you put a flanking sub, it comes up to about 6 decibels down, because you're going from 2 to 1. So it's natural you get 6 decibels. So I get the mitigation of SBIR. I get higher frequency room mode mitigation. I get the baffle step. And being a sub, I get, what a traditional sub's used for. I get extension.
Right.
So sorry for the sales pitch, but just for any DIYer, that's a cool, easy trick to do. It is, you do that with another couple of subs to be a multi-sub configuration. You got the best of both worlds. The multi-subs are run by a summed, all channels in signal. The flanking subs, that is getting a low pass copy of the signal he gets. So there's that slight difference.
Yep.
Flanking subs get the low pass signal of the main they're flanking, but multi subs get the LFE channel. Still, it's a part of the same approach.
I love it. It is truly an awesome system. Now, what offerings do you have, and what is the difference for them? So the people that are watching that say, well, Wayne has Pi 3s in his own room. Why a Pi 3 versus a Pi 4, a 1, right? And then you have the big boys as well. So if you don't mind going into a little bit of how somebody would select one over the other, that would be great.
Oh, okay. Yeah, thanks, Jason. The 1 Pi and the 2 Pi are just a simple two-way cone dome speaker. Where I like those is if you got it's your bedroom, small room, or a dorm. It's a great little entry level system. They're inexpensive. They're tube amp friendly, so they can run tube amps or solid state. But where I also like them is the surrounds. Surrounds don't really need the directivity of the mains. And so I often will use 2 Pis. That's my personal. 1 Pis or 2 Pis is fine. But, set them up as surrounds. There is a hybrid. I did these, I don't know, 20 years ago now, but it wasn't in my normal line. But I make a 2 Pi tower. And it's because the mid woofer used in the 2 Pi and in the 8 Pi has some unusual characteristics that make it where it can really hit the low notes. It's an inexpensive 10-inch woofer. It's an eminence part, but you can put it in a 2 cubic foot box and it sounds great down to like 65 hertz. That's what a regular 2 Pi is. But you put that thing in a 5 cubic foot box, it's still flat. It's nice and flat, but it'll go down to like 40 hertz, 35, 40 hertz. So the 2 Pi tower is great if you're on a budget. You don't mind a tall standing tower. They sound way better than they have a right to. Then I'm going to jump to the top of the line.
Sure.
The 6 Pi and the 7 Pi are my corner horns. They were my original flagship speakers. In my opinion, they do everything right. The problem is there are an awful lot of places that don't have the right corners. Your best home to use corner horns is something where you're not bigger than about 30 feet across, maybe even 20, but you're not less than about 10. The corners are unobstructed for 6 feet out. Your listeners can sit behind where the forward axes have crossed. It's a lot of simultaneous things that have to happen at the same time. If you've got the room that'll work in, great. It's your best bet. You can put a couple of subs in the opposite corners, and it's just you've got multisubs, and you have no problem where you would need flanking subs because you're tucked in the corners. But again, the problem there is getting a room that supports that. So then if you don't have that room, then we use this kind of a speaker. There's the 3-pi and the 4-pi. What those are is a two-way speaker like this. The 3-pi has a 12-inch woofer. The 4-pi has a 15-inch woofer. Other than that, they're just about the same speaker. Right now, the fully upgraded 3-pi is all Italian. It's a BNC midwoofer and a BNC tweeter. So that's kind of funny because I can have my own little Ford versus Ferrari thing.
That's right.
Because the 4-pi uses JBL, which is American made. Both are awesome. Both have shorting rings in the midwoofer. And then of course you'd use the flanking subs. I make those subs. Subs aren't critical. You can get any good direct radiating sub to act as a flanking sub. I have these huge bass horns, but they were really done just to do it, just to see what I could do to make the best bass horn I could make. I wouldn't think that many homes could use them in the home, but they're great for a football field. You don't need many of them. It was just a show off piece. And then lastly, I do have this one hybrid kind of weirdness, just like the 2-pi and the 2-pi tower, and it uses the same midwoofer. And because that midwoofer, it actually works really well horn loading. I can use them in corner horns. So I made this thing that looks like a mini Vought out of them. And it's, in a way, it's like an entry-level corner horn. Although they don't really have to go in corners. So that one's a hybrid, and that's fairly new to my line too. I say new since I've been doing it for 40 years. This thing isn't that new. It's probably 15 years is when I started making them. But yeah, it looks like a Vought. It's got a mid horn. It's a large box. It's vented for the bottom end, and then it's got this kind of waveguide up top.
All of your offerings are available as a full kit, correct? Which includes a flat pack?
I do. I have you can buy my speakers outright from me, although the cabinet shop is slow. But the good news is you get to pick exactly what you want. If you buy a full speaker, you tell them the wood you want, whatever, they'll bid it. And they treat it like a job shop. But they're slow. I'm sorry, Mike Lundy, if you're here and I'm telling on you.
He's the one that does it? Okay.
Yeah, he's the cabinet maker. He's in Tulsa.
Yep.
He also goes to all the audio shows with me too. He's he builds a lot of stuff for a lot of people. He makes flat pack kits for me. The flat pack kits are available for the 1-pi, 2-pi, 3-pi, and 4-pi, and the mid horn. We're talking about maybe making a flat pack for the 2-pi tower. But the reason that we didn't focus on the 2-pi tower or the corner horns is by the time you get a flat pack kit made, it's still physically large panels, and they get expensive to ship. You may be better off finding a local cabinet shop to cut the panels. I did make flat pack kits for the bass horns, but those are palletized. They're huge. And we weren't even worried about shipping costs with that because it's CNC cut and it needed the precision. It's nuts. Um, so that one was, even though the shipping was expensive, well, you still were better off buying the flat pack kits. But I don't feel that's true on the corner horns. They're pretty simple to make. So
Okay.
anyway, flat pack kits 1, 2, 3, and 4, and the mid horn if you want one. But then you can buy the driver kits from me for any of my stuff. And what comes with that is an assembled crossover for the 3, 4, for all of them except the 1 pi and 2 pi. It's on a board. It's a crossover board. The 1 pi and 2 pi is simple enough that the crossover is built as a cable assembly. It's the hookup to the drivers.
Huh?
But when you buy a full kit, you get all the hookup stuff, the panel, the plate, printed copy of the plans, and all the drivers. Those are separate though. A driver kit is one thing, and a flat pack kit is another. You can buy them separately, and in fact, you have to. I don't have the kit that's all
Sure.
of it. But then, like I said, the last thing I offer is you don't have to buy anything. This thing really has always been kind of a hobby to me. You can buy just the waveguides from me and build everything else and source everything else yourself.
If somebody buys a driver kit, are you the one that's personally putting that crossover together?
Yes, I had my oldest son making them for a while in the 2000s. I may start getting my youngest son to do that. Both boys could solder, and
Good.
but my youngest son right now is at an age where I wouldn't. He's at that age where you don't. He's got more focus on going out and playing than soldering. So it's been me for a while, and instead of having a stock, I tried for a while. I'd have a stock of all these different crossovers that were popular. But since I offer 3 or 4 different capacitor brands, a couple of different resistor brands, and then of course my line is like, well, 1, 2, it's like 8 different speakers in the line. When you put all that together, I just have too many different things that I'd have to stock. So I build them to order. Doesn't take me long. What does take long though is the coils are attached to the crossover board with silicone adhesive that acts as a cushion. And it's a big old glob, so it takes a while to cure. So I always tell people, you order, expect them in like 2 weeks to a month.
Okay. And if somebody orders a flat pack and a driver kit, it gets to their house, how long should they expect to really take to assemble everything? Glue it all together, mount everything. Can they do it in a weekend?
Yes, a person could, but if you're 25 or younger, yeah, you're gonna get that done in a weekend because you're crazy. You just got to get it done. Got to get it done. And I would have too. But I do suggest, I've just found as I got older, I do a lot better work if I'll take my time.
Sure.
So, yeah, I mean, you can get it done in a weekend, but I'd suggest glue those cabinets together, clamp them, and then go away for a little while, let them get done, and then come back in and take your time, to assemble them, and let it take a week or something.
Sure. And available for tech help, you are on your forum, correct?
Oh yeah, you probably remember that. I check my forum a good several times a day, and I respond there or emails. And some people will talk on the phone. It seems like all the guys when we talk on the phone, we end up spending an hour, and so we're in trouble with both our wives. But whoever I am, whoever the other guy is, and me, so I take calls too.
Okay. Wayne, is there anything that I should have asked you that I did not, or anything that you would like to share?
Well, I think we covered it all, Jason. Oh no, I do know one more. You remember because you've been there. I always show up at the Lonestar Audio Fest every year. Back when I started my forum, I noticed several small companies like mine that made either speakers or tube amps or something. And we were a bunch of folks that tended to, have companies like mine that we sold things online. We didn't have a showroom. We didn't have a dealer network. And so we just started showing up at a hotel in Dallas every year. I kind of put that together. there's been other audio shows that have sprung up over the last couple of decades since we've been doing that. And some of them cater more to some super high end. Ours caters to kit builders like mine, but all are welcome, and lots of larger companies come. This year we moved that thing. I don't know if you knew this, Jason, but I met a gal that does the show in California, and her name's Emiko Carlin.
Okay.
And she's a Los Angeles girl, right? She's a musician. And so Austin's more her style with South by Southwest. Well, when I first started the show, it was in Tulsa. When we moved to Texas, it was to get a bigger market. And I was debating. I was commuting to the IBM Research Lab in Austin during that period. And I thought about Austin. It seemed the right kind of place. But we didn't. We chose Dallas, and we've had a lot of fun there. But this year, first weekend in May, we've moved the show to Austin. We're gonna meet at the Round Rock Embassy Suites.
Wow.
One thing I will say, just to be real honest, you remember you were there a few years back. Mm-hmm. We love those Embassy Suites. They got the big atrium. It's just fun. And the suites were really great because it's not terribly expensive, and you can sleep in the back room and set your front room up like a little living room. I love that. The Round Rock one does not have the atrium. It's one big long, so we don't have that feel. And the rooms are a little smaller. I don't like that. The rooms are small enough as it is. But it has a huge downstairs. We got a whole bunch of people downstairs. Nice. So I'm excited to, it's change. It's going to be interesting. And we're going to feel it out. If we all set up and live in that room for the weekend. If we all like it, great. We'll stay there. If not, we may move into a different, there's several suite type hotels in Austin that had the same approach where front room and sleeper room. So anyway, if you want to come hear these things, to the crowd, join us, at the Embassy Suites in Round Rock, Texas, near Austin, and that's the first weekend in May.
And I'll put the link below for that show. How many vendors are you expecting?
I don't remember because I let Emiko kind of run it this time. I mean, that's what they do.
Okay.
But it's more.
It is more.
You remember when you came, we'd always have like 200 or 300 attendees. It's a pretty small laid back show. Yeah. You can hang out and talk to the folks all you want. And that's what I loved about it.
Yeah, it was awesome.
This time, Emiko's selling tickets.
Wow.
So, but they're cheap. I mean, you're supposed to pay $15 to park anyway. If a guy had a room, his parking was free. But for the attendees, parking was $15. Well, probably nobody ever paid that, but that's what it was. Emiko's charging $15 for the tickets, so it's a wash. It's the same as,
sure,
it's not big money. Anyway, why I say that is she's got a count of how many people are coming, and then it's like 500 already. So I don't want the show to get to be this big unwieldy thing. I like it's being a personable show, but it looks to me like we're growing a little bit.
Sounds like it. Sounds like Pi Speakers is going to be a little busier after that show.
Yeah.
What is the plan going forward for Pi Speakers? You mentioned your kids. Do either of them show any interest in the company?
I've thought about that. And when I was younger, I really kind of assumed that, one of my boys would take over this business. They're technical, but they're not as technical, certainly not in acoustics. So I guess what I'm saying is time will tell. To be honest with you, as I grow closer to retirement, I know I've got many years where I'll still be doing these shows and still be selling my kits even into retirement. But I have thought, if I don't, if my sons don't want to do this and I don't see that they have the zeal, I probably would find somebody that would buy this, because I've always treated it as a hobby, and that's nuts. As I told you at the beginning, I'm a computer guy, and that's what's earned my money. But ironically, I got more intellectual property in speakers, my hobby. I got 2 registered trademarks. I got a patent. I got copyrights, registered copyrights. It's really kind of stupid in a way that I have just let this thing be slow speed where I'll sell several kits every month, but still, I mean, these things are pretty competitive. So all that to say, I don't know if my kids will take it or if I'll sell it.
What's your patent in?
You remember that big bass horn I told you about?
Yes.
All right. It's the cooling system. When I was making it, I vented, it's got a cooling vent anyway. Loudspeakers usually do, right? The woofers.
Sure.
I was going to duct that into an intercooler. Okay.
Wow.
Yeah. And I did, and it did absolutely nothing. And I realized, okay, the forced air cooling from the movement of the diaphragm does do a lot, but just the huffing and puffing of moving back and forth does as much as you're going to do, because ducting it to an intercooler did nothing. There's not like, I mean, if you had it inside a box, that box will get a little warmer, but it's not like getting so hot that
Right.
you need an intercooler. That just didn't work. And I'm talking big bass horns that you like energize a football stadium with. This is a lot of power.
Sure.
But so, and I mean, I'm testing that. That's the other thing. When you look on the Pi Speakers forum, and you do the FAQ, look at the stuff about the technology of the bass horn, and it shows you all these measurements. So I shifted. I decided, well, I'm gonna shift what I'm doing to cool, and I basically put a cooling plug. I put a plug in the vent that still allows venting, but it uses, it conducts heat away. And that really increased the power handling over 200%.
Interesting.
And so it was significant enough. I thought, man, I need to patent that. And that's what the patent is for.
Has anybody tried to do that? I mean, obviously there's other companies, JBL being one of them, that does massive stadiums among others. Why do they not have an issue? Are they using a different technology, or do you license that patent out to other companies?
Well, no, actually I don't. And I thought about that too. It's kind of like I said, being a hobby and really not being in pro sound. And pro sound is a different breed. I did find that out because I was kind of pushing those bass horns for a minute, but they're a different breed. It's not for hobbyists. So I didn't engage that very well. But what I've seen is, and you've probably seen them too, I've seen drivers that had a pole piece that's exposed, but they're usually calling it like a phase plug.
Right.
It's almost decorative. Mine, you see, it goes out to a large heat sink. Mine's a heat sink. Well, and I've seen that too. Eminence did that. They put a heat sink that's about the size of your voice coil cap. That goes out in front of their Kilomax speaker. But mine goes out the back, and it goes to a very large plate, which also it serves double duty. That's the access hole to get into the bass horn cabinet. Yep. You put the woofer in, you bolt it in. They're both facing what looks like inward, although one acoustically drives the horn from the back of the driver, and one acoustically drives from the front. So I have a push pull that reduces distortion that way. But anyway, the woofers are physically going this way. You bolt them in, and then the plate goes on. It's gasketed. That plate is aluminum, and the cooling plug touches that. So, I mean, you don't want those exposed to sunlight if you're, because that would be going the other way. If you're going to be in sunlight, you put a denim cover over them just to keep them out of direct sunlight. But man, that thing really worked. And so you're right. I should be out there like licensing it or something because it works.
Well, Wayne, I can't thank you enough for your time and your knowledge. It has been fantastic taking this much time on a Sunday, so I really do appreciate it. Perhaps I can get down to Texas and see you once again in May. For everybody else out there, please go visit piespeakers.com. Check out Wayne's offerings as well as the forum. There is an incredible amount of knowledge on that forum, and I really do suggest you read through it all. Thank you so much, Wayne. I appreciate it.
Well, thank you, Jason, and I do hope you can make that run from Florida at least sometime. We'll get us some barbecue.
Understood. Definitely. Best barbecue I've ever had.
I know it's good.
Thank you so much.
Thank you, Jason.
Thanks for listening. Find us on YouTube and Facebook at the Intellectual People Podcast and online at theintellectualpeoplepodcast.com. Check back for exciting new episodes.